All right, so this first part of 6-6 Day 1 is just going to be a review of the law of exponents. It's going to end up helping you when it comes to the radicals because we're going to end up applying the same rules. So one way to remember it is to kind of use this chart. If you have exponents, you're going to multiply those exponents, meaning parentheses, power to a power, you multiply them. If you are multiplying and you have exponents, then you add the exponents. So multiplying, like this first one, we add the exponents. If you have division, you subtract the exponents. So here we keep the same base, we add the exponents. Here we have the same base, so we subtract the exponents. Here, power to a power, or we have the multiplication, or we have the exponents, so that means we multiply. So exponents multiply. So 3 to the 6th. Simplifying radicals, we just got done doing that. So remember, we find the biggest perfect square, and then we simplify the one that's perfect. And then this last one, if you can simplify that fraction, do it. If not, then you're going to go ahead and rationalize by multiplying by the radical in the denominator spot. You can go ahead and multiply the top, and if you got that, or sorry, simplify the top, and then multiply by that radical, which would give you 2 radical 35 over 7. And then down below here, remember fractions. When you add and subtract and multiply and divide without a calculator, adding and subtracting is a little more difficult because we have to have the same denominator. So multiply by 3, multiply by 4. So we get 9 twelfths plus 8 twelfths. Now we can go ahead and add them, and we get 17 twelfths. And then you could reduce it if needed. Subtracting, the same thing. You need to have a like denominator. So multiply by 2, we get 10 fourteenths minus 8 fourteenths, which would give us 2 fourteenths, which you could reduce to 1/7 if needed. Multiplication's a lot easier because we can just multiply across. So multiply across on the top, get 6, multiply across on the bottom, get 12, and then reduce. Division, we can't actually divide by a fraction, so we have to multiply by its reciprocal, which means we flip that second fraction, only the second fraction, and it changes it to multiplication. And then we can go ahead and multiply across, or you could reduce. Since this is 7 and this is 14, we could divide both, and you wind up with a 2 up here. Since we just took that 14 and that 7, basically taking out a 7 from each. And then you could take out a 2 here and take out a 2 here, and then multiply across. 5 times 1 is 5, or 1 times 4 is 4. Or on your calculator, take 5 times 14, 7 times 8, and then do the reduce button. But again, we're trying to do it without a calculator. So we could practice some more of those if needed. So all of those skills are going to come in handy in this section. So what we're doing in this section is we're rewriting it. A rational exponent is an exponent that can be expressed as m over n. So meaning you can write it as a fraction if it's rational. So that means that we're going to turn it into anything that has an radical or some sort of root, we can turn it into a fractional exponent. So vice versa. If it's got a fractional exponent or fractional power, then we can go ahead and turn it into some sort of root. So 1/2 is really the square root, so power here. And then 1/3 is the cube root. So you kind of see that pattern taking place. So these laws of exponents tell us how to handle exponents when we multiply. So remember that we add when we multiply. So that same thing happens with fractions. They're still exponents. So when we multiply, we add those exponents. So on the next page, page 15, what do we call a number that when multiplied by itself gives us another number? Well, a perfect square. So those same kind of rules apply. Let's go ahead and kind of take a look at how this works. So basically, when we take a root and we multiply it by something, some power, the whole number, let's say m, and then the fractional part, the 1 over n, sorry, the m, and then the 1 over the n, and we multiply those, the m ends up on top because it's the big number, and then the bottom is our n, so it ends up as m over n. And then how we end up with that is the bottom number ends up being our index, and then the top number ends up being our exponent. So there's a trick to kind of remembering how this works. This is all the logistics. Let's talk about the cheesy way that Miss Parker uses this, but it's awesome, and it's a great way to remember it. So think of it as flour, power. So the top, kind of think of us like as our fraction, as the power on top. Flowers grow up and the power's on top. So this is kind of our fraction bar. So below, those are the roots. So as we look at a fraction, we can use this up here, this is our power, our flour power, up here, and then the n is our root. Okay, so kind of think of it that way. So for these first few, we're just going to go ahead and practice that concept of writing them out. So for example, if the power up here is 1, then it's like 64 to the first, but we don't really need to put the 1 here. You can if you want to. And then the bottom is our root, so 3, it's the cube root. And then you can go ahead and simplify. Oops. And so if we look at our chart and we use that cube root of 64, we would get 4. So our final answer is 4. So on the next one, we have 32. So what's going to go under? What's our root? Well, our root is 5, so it's the 5th root of 32. You can either take the power and put it inside here, or you can put the whole thing in parentheses and take it to the 3rd. Either one is going to be correct. So then you could go ahead and simplify. So I'm not going to focus too much on the simplifying since we spent 2 days on that, but next one, 2, so that means it's the square root. We don't really put the 2 out there when it's the square root. And then we could go ahead and divide 24 by 4 and break that down and then simplify that. So try those next 2 on your own and then check when you're ready. All right, so here's number 4, just that first step. And then if you haven't simplified, go ahead and try and simplify this one and then check when. All right, so cube root, we can break this down as 8 and 5. The 8 becomes a 2, the 5 stays under. Then we look at a to the 7th. We can take 2 groups of 3 out. So there's my a squared. That would remain 1 a left underneath the radical. So try number 5 if you haven't already and then check. All right, so number 5, 48, we can break down as 8 and 6. The 8, cube root of 8 is 2. The 6 stays under. And then x to the 10th, take out 3 groups, and then that remains 1 underneath. So going the other direction down below here, we're actually going to write it with the roots going the other way. So if it is, oh, so it looks like we still have one more here, that 5th root of negative 3. 25. So on these next ones, we're going to go ahead and write it with the fractions. So if you want to go ahead and simplify this one, it is a perfect 5th root, and that is 5. And since it's odd index, that negative comes out as a negative. All right, so let's go ahead and take a look at multiplying or writing these with the fractions. So we take the 40. X to the 4th, and I'm going to go ahead and make this so if the root is 3, then I put the root of 3 on the bottom, and then there's no exponent taking these, so I'm going to go ahead and put a 1 there. So for the next one, we have 32x to the 5th, and then we have it, the 4th root is 1 there. And so try those last 2 on your own and then check when you're ready. All right, so check your answers for number 9 should be 16n to the 1/3 power, and then the number 10 is 135p to the 1/3 power.